Same paper, make sure I can tell. Whenever you make any corrections, don't change the original work at all. Either do it on the side or do it in the back or do it on another piece of paper. Right? You would turn in the original and the corrections.
Okay.
So you can see what went wrong and hopefully what went right. Okay, so any questions from homework? Yeah. Oh, what's your name? Robert. So hopefully I got a few more turned in today, the survey.
Oh yeah, you did.
All right. So now, any questions from homework? You guys said earlier you had, oh yeah, we got questions. You said
Well,
like
I
number
figured
12.
it out.
Oh, sweet. That's the wait and see form of tutoring.
I can give you a number that I have a problem with. I couldn't figure out 14.
14 where? Chapter test?
The page 83, I believe.
83.
Right, page 83?
Yeah. All right, guys. So this is from the chapter test, page 83, number 14.
Yeah.
Yeah, it just looks ugly. Let's see. 30 times. Where'd it go? There it is. -1 minus 2. Over -9 times 3 minus -2 minus 24. What? So tell me, remind me, what's the last thing you would do here?
Divide.
Beautiful, right? That bar in the middle says do the top, do the bottom, and then divide them at the end, right? So on the top, it's not too bad. Is it?
No.
Because what do you do first on the top?
Distribute.
You
Find
add
You could, but
-1 and you get 3
Yeah.
times -3.
really, the only time you distribute for real is if the inside has variables, not like terms. Otherwise, you follow order operations exactly. Distribution is sort of a way around order operations. What can we do on the bottom here? Let's see if we can handle doing both at once. What's the very first thing I do here?
Do the brackets.
Good. So doing here first?
Yes.
Because those brackets are just another form of parenthesis, right? So they're the top of the food chain. Yeah. So -9 times. Now, how do you do 3 minus -2?
plus.
Bam, bam.
I'm seeing way too many 6's in there.
Yeah, 3 plus 2.
What people do is they'll say 3 minus -2, and they'll say, okay, 3, and then -2 is +2, and then they think it's multiplied. And you'll see me say all the time, subtraction cannot magically become multiplication. So be real careful. You mean to say 3 plus 2. That's negative makes a plus. So then inside there should be 5. Cool. And what can you do here?
Level 12, 24.
Exactly. Negative times negative is positive. 24. I love it. Because that's multiplication. I can go ahead and do that. The subtraction I've got to do at the end. Cool. It becomes addition because it's a minus and negative.
And we do multiplication.
Yeah, down the top. 30 times -3. On the bottom, what do you do last on the bottom?
9.
You add last. So multiply before addition. Yeah, so that's
Or -45.
-45 plus 24.
Just 90 over -21.
Yeah, so -90 over -21. And now what do you always have to do with a fraction at the end?
Reduce.
See if it reduces, yeah. And this one definitely does.
3.
Yeah, 3 goes into both.
Yeah.
So one thing that dies right off the bat is the 2 negatives, right?
Yeah.
So they cancel. 3 goes into 90. 30 times, 3 goes into 21. 7 times. Cool. And you could, if you wanted to, make that a mixed number. You don't have to. The book lists both answers, just in case. Yeah. Yeah.
Whenever there's 2 negatives, do you always have to cancel out?
Yep.
Okay.
And really, the reason 2 negatives cancel is because a negative is kind of an opposite, right? Because negative 3 is the opposite of 3 additively, because negative 3 would cancel 3. So if I said negative 3, what's the opposite of 3? Yeah. So like me saying, turn around 180 degrees, now turn around 180 degrees. I'm facing the damn same way. What did you do that for? Right? So
Right.
they undo each other, these two commands. So multiplication and division is the same way, because that negative you could just bring it up top. And negative, just like we just did, makes a plus. Cool. Okay, maybe. So is that cool? Any other questions on that? And you've got to be really honest with yourself. I'm seeing a few people turn in the test and the review, and it's really rough. Right. And one thing is, go get some help if it's not coming out right. All the answers in the back of the book for the test and the reviews. You should be able to check them yourself, and if they're not coming out right, go get some help. You have until the day of the test to turn in. At the same time, I appreciate you doing it and being honest about it, and then I can tell you what's going wrong, and you have to correct it, but hopefully then you'll go get help, specifically on the things you missed, right? So it's not a bad idea really either. But if you're having a lot of trouble with Chapter 1 review and test, you shouldn't be, really. Unless it's, if it's been a long time, hopefully it'll come back.
Working on it.
Yeah. Working on it. That's all I can ask, yeah. Let me see, what was it now? What's
Well, 18.
18 still on the test, right?
Yeah.
Okay, so 18 was one of these plug and chug deals, right? Let's see if that was better. Oh yeah. But they tell you that x is negative 2, y is 4.
Yes.
Cool.
18, this is, I'm sorry, test or?
Yeah, still the test.
Still the test. Okay.
So the mistakes I saw in this were kind of basic mistakes. A big problem was somebody did this but didn't distribute the 3. Or what you really should do here is just add these together. So don't do any work really yet, because there's really nothing you could do. Throw the numbers in, and then you can do a lot of stuff. So 5 times
Negative 2.
negative 2 plus 7 times
4.
4. Just throw the numbers in. Over 3 times
Negative 2.
negative 2 plus 4. All right, and now you attack it the same way. It really looks a lot like 14 that we just did. Actually, not even really as evil. There's a little less going on. So it's the same idea, right? I do that division last. I've got to do the top first, the bottom, and then I can divide at the end. So what can you do on the top? Yeah, because you're going to add last. PEMDAS. A is way at the bottom. So 5 times negative 2. 7 times 4. 28.
And 3 times 2.
Yeah, 3 times 2. Now, it's not wrong to distribute, but it's sort of extra work in a way.
That's
Good. So negative 10 plus 28
And then reduce.
is 28 minus 10. That's 18. Over 6.
3.
3.
Cool.
Exactly.
Now, not to make anybody feel real bad, but you got to know your multiplication tables. I'm seeing a lot of 7 times 3 is 24, that kind of thing, where it's repeated. I can understand if you have a brain fart for one problem, but if I see 24 for 7 times 3 in a lot of different places, and again, not to make fun of you, just got to go back and review. You got to know those multiplication tables. You got to know them, because this kind of problem shouldn't take you an evil amount of time. And if you use a calculator, a lot of times you still make a mistake because you have to put it in the calculator correctly. And I can catch those mistakes because I know what to kind of expect if you're using a calculator wrong. Like, oh, you got the 1.74 answer. No, you tried it in the calculator. You didn't do it the right way. Okay. So any other questions from homework? See if you're catching all this stuff. Yeah, for the most part. So no other questions from the homework? Okay.
How about 132 from the practice?
132.
From the practice. Page
20. Alright, so last question here. 132 is one of those translation questions.
8. Right.
From English to Mathish. 132 is definitely kind of a weird one to read through. A number multiplied by 8 added to, okay, stop. All right, so I need to add something that I don't even know yet to something else. So what is a number multiplied by 8?
X8.
8x.
Good. You could put x8, but we know we always put the number as a coefficient. Added to the sum of 5 and 4 times the number. So added to the sum of 5 and 4 times the number. So what do I want to do here? I want this to be the sum of 5 and 4 times the number.
4.
So it's not 20 something. It doesn't say multiply 5 and 4.
No.
It said the sum of 5
5 plus
and
4x.
4x.
4 times the number, yeah. So I was saying, when you see the sum of, okay, they better give me two things separated by the word and that I must add. The sum of this and that. This plus that. So it's direct translation from English to math. And then it does say simplify this. So I saw a few people write this down, but they didn't simplify it. So the next step is you should actually add what you can. And of course, what can you add here?
Texas.
Yeah, the like terms, the x's. So when you do that, you get
12.
12x plus 5. Poor little 5's all by himself. Or herself. I can't say. Okay, maybe. So, like I said, you've got to be honest with yourself about how this chapter 1 has gone so far. Right? Yeah. Yeah, the test is on the homework sheet. I can tell you now. That's what I mean. Oh, quiz. Yeah, now that I can tell you. No. The homework is always due by the day of the test. So the word test different from the word quiz. The word quiz, that we're gonna have a quiz. Yeah. The homework's not due then though. Ooh, I thought it was. So there will be a quiz. You know that Monday's a holiday, right?
Yes.
So only come if you want to sit around the school. They won't even let you on campus. So a quiz a week from today. Wednesday, I think that's the 7th. Chapter 1. Chapter 1 and section 2:1 and 2:2. What about the homework? Put it here. Yeah, Monday you're not going to see me, so it's fine. That's the quiz, yeah. So even if that was the test, you can still give it to me on the day of the test. It is due by the day of the test. Cool. I love it. So the one thing you could do, but I really hope you don't do, is give me all of your homework on the day of the test. You could do that, but please, dear God, don't do that. Right? Okay.
I just wanted to go back to that. You can just destroy the parentheses and everything.
Yeah, because what's in front of here?
1.
Understood, 1. So if you destroy the 1, they stay the same.
Yeah, okay.
Yeah. You don't even need them at the beginning. I just did that because they made the sum kind of separate.
Right. Okay.
But you don't really need them.
Can we do without brackets?
Yes. You don't really need those parentheses. I just put them because they put these guys kind of together. But there's a 1 in front. Nothing would change. You can just take them out of the way. Yeah. I did see a little too much of this, though. I saw something like this, and then it became -4 minus t. What was the mistake?
Plus T.
Yeah, negative times 4 and negative times negative t should be plus t. So be careful. That negative's got to distribute to both pieces. Negatives always get us. Stupid things.
Yeah, I was trying to figure out if the negative followed the number or if it stayed in there. You had to use that as a function.
So think about it like as a negative 1 out there. You got to distribute that number through.
Yes. So the
Multiply it through.
expression before the letter is that you have to use that in the distribution. You don't just leave it there.
Yeah. So then negative times that, negative times that. Cool. Bring that negative through with you. Yeah. Okay. So I think last time we stopped right before what we've been waiting for, which was the word problem section. Let me do. There's one kind of problem I didn't really do last time with you guys. How would you do this problem here?
Which section is it?
This is section 2.3. So remember real quick, section 2.1 focuses only on x plus 5 equals 7. You got to subtract or you got to add. Section 2.2 focuses on multiplying or dividing. Section 2.3 is everything at once, right? And section 2.3 gives you problems like this: 0.2x minus 0.7 equals 3. So one way you could do this is to leave the decimals in there and just attack it like normal. Another way to do this is just the same thing you do with fractions, because what are decimals? They're fractions that have a bottom based on 10. And the reason we write them in a special way is because our number system is based on 10. Right? So that's why this is really, what number is this really? What fraction is this 0.2? 2 tenths.
Oh, sorry. That's fractions. I was thinking the 2.
Oh, the 0.222, no, yeah, it's just 0.2. So that'd be 2 tenths. So what you could do then, just like with fractions, how do I kill fractions in an equation? I multiply by the LCD, the denominator, right? So this has got what on the bottom?
10.
A 10. It would reduce to 1/5, but leave it as a decimal, so it's 0.2, it's 2 tenths, it's got a 10. This has got a 10. And another way to look at it is I just really want the decimal to move once, and then I would get a nice whole number. So I multiply by 10 to make it move once, right? 100 to make it move twice, so forth. So if I multiplied everything by 10, and you don't not multiply him, and I know it's a double negative, but I'm allowed to do that. You don't not multiply him by 10 just because he's not a decimal. You got to do the same thing to both sides, period. So you have to multiply him by 10 also. What do you get here then if you do that? 2x.
So minus 7.
7 equals 30. And you know, that just looks a little nicer. Some of you guys who wouldn't do this realize that it's the same stupid problem either way, really. But it just makes it look a little nicer if you don't like decimals running around. Right? Now how would you keep going?
Add the 7.
Get rid of the 7.
Beautiful. There's no like terms on either side, so you start moving stuff around. Get your numbers together. So 2x equals
37.
37, so almost always divide last 11. So x equals 37 over 2. Not overly pretty, but who cares? We're done.
Whenever I end up with an answer like that, I always think, God, really?
Oh yeah, really.
You know what I mean?
Totally.
I always think it might be wrong. Go back and do it again.
I think about it like things won't cost exactly 18, 19, 20 bucks. It will cost something. And this is $18.50 if you look at it as money, right?
Yeah.
The way to do it quick is 36 divided by 2 is 18. This adds 1/2, so it's 18.5, $18.50. Cool.
Good point.
Okay. So let's get into the next section, which is the fantastical word problem section. And the funny thing is, a while back, they decided to call word problems application problems to maybe ease off the anxiety a little bit, but we can be honest about it. I'm going to show you the way that will keep you straight. If you don't do it, fine. If you don't do it, you will be more likely to make mistakes. Trust me. So the way that I look at it is, and the problem, I think the problem that a lot of students have with math in general is you guys somehow think that you must get to the equation immediately. And if you don't, you're not good at math. And that's just silly. The way I teach it is the first step is not math at all. When you're looking at a word problem, the first step is purely what the hell is going on? How many players are there in this problem? So let's look at an example.
Yeah.
Here's a beautiful example.
So,
Yeah, oh, sir.
well, if I do other way, the answer is the same. Is that okay?
Yes. Better be the same, or else one of us did something wrong. Yeah. Cool.
Would I give my
That's what I said the first beginning. You could leave it the same way, and then I said, or you could do this.
What I did in my country is either way, but our answer is always the same.
Has to be.
Okay.
Okay. Look at page 109, if you can.
Yeah.
So example 2. Let me try to summarize it for you. In 2006 Winter Olympics, the U.S. won 11 more medals than Sweden. Together, they won 39 medals. How many medals did each country win? The thing you have to be careful about with this, and I understand the frustration, but a lot of these problems are purposefully made simple so that you can kind of check it by just making the numbers work. But that doesn't mean if you get the answer just by thinking about it for a minute, you can't just put it down and be good. Hell no. What's the word? What's the key word in this title of this course? Algebra. Right? So we're here to practice algebra. So this one, I'm sure some of you guys could certainly just figure out what it's got to be to make it work. Not good enough. Right? Not good enough. I've got to see the algebra because, great, you can do this problem. What about a little more complicated problem that you can't do it in your head then? What if I had 4 different countries? And one was 2 more than 8 times the other one, and the other, you know.
Right.
So here's the steps for this, right? And I think I'm going to go step through this once on the board, and then I'm going to give you this handout with some example word problems on it, and we'll do a few examples, and then I'll let you guys try a few examples. Okay. Step number 1 is not mathematical at all. Let go of 11, let go of 39, let go of more than, let go of all that crap. Step number 1 is just how many things are involved in this problem. How many players are there?
2 players, three pieces.
There's really just how many players? How many players? How many things? How many objects? How many people? How many things are involved in this problem? There's really just 2. What are they?
U.S. and Sweden.
U.S. medals and Sweden medals, right? Now I know they do stuff together, but that doesn't mean there's a third thing in there. There's not a third country. There's 2 main things. The number of U.S. medals and the number of Swedish medals. So that's step number 1, is purely English, right? Just tell me what is involved. So if I said, like, Fred makes twice as much as Bob, and Bob makes $100 less than Sammy, how many players are there? 3. Fred, Bob, and Sammy. So that you just write Fred, Bob, Sammy. And actually be a little more specific. Fred's salary, Bob's salary, Sammy's salary. Right? How we doing so far? This is a step that people skip, and then they get funky answers, like negative side links. And I'm like, wow, that's freaky. Step 2 is which one is going to be X? Because I don't know crap about either one of these individually, do I? I know together they make 39 medals, but I really don't know anything about them individually. I do know how they relate. The U.S. won 11 more than Sweden. So which one do I have to know in order to build off to get the other one? Which one does the other one depend on?
U.S.
U.S.
Well, the U.S. depends on Sweden. So, like, for example, just looking at that sentence right there. If I said Sweden had 7 medals, how many would the U.S. have had? 11 more than that.
Yeah, 18.
18. So if you know what Sweden is, can't you build off of that to figure out the U.S.? If Sweden was 7, then the U.S. would have to be 7 plus 11. Well, how many did Sweden have?
X.
Beautiful. Because I don't have a freaking clue. So the problem is, I don't want to just deal with blank spaces showing me where I don't know something. I need a placeholder. So they just picked the letter X to be our placeholder for what we don't know, right? We weren't there, so we couldn't say, oh, I like the letter D. No, we weren't there. So whoever liked the letter X, Xavier stood and said, I like the letter X. And they said, sure, why not? You're the first one said. So step 2 is, which one is just X? How we doing so far? Almost always in a word problem, there's something just X, and then the other things are like 3 more than twice that, or 6 degrees less than that, right?
Right.
But you can't build 6 degrees less than something until you got what the hell that something is. So, like you guys said, Sweden would just be X. Step 3 then is build the other people, build the other players off of that. What do you know about US compared to Sweden? Has 11 more. So Sweden is X. What's the US got to be?
X plus 11.
11. So step 3, build the others off of X. Right? You guys should know when I say that. You've seen these things before, hopefully. Maybe it's been a while, but you remember the length is 3 more than twice the width. So if you call the width W, then you can call the length 3 plus 2W. You have to have that W first before you can build the other guy. Okay. Now the minute that we have, now I want to point something out. Here's the English names of the stuff that we got going on. Here's the math names of the stuff we got going on. Which one, of course, can I build an equation off of? The freaking math names, of course, right? So what is the what are these two supposed to do together? Do they equal each other? Do they?
They add up to 39.
Yeah, they got to make 39. Yeah, so that's where this guy finally comes in. So if I add the number of medals the U.S. got to the number of medals that Sweden got, I got to get 39. I like it.
What was that? The number, okay, U.S., Sweden.
These two together have got to make 39 total.
First time it was just X plus 11.
Not good?
It's not just X plus 11.
Tell me in English what's got to happen up here. What's got to happen with the U.S. medals and the Swedish medals? What must happen according to what they say here? If you take the U.S. medals and you add the Swedish medals, you better get...
39.
Well, what is the U.S. medals?
X
How
plus
many?
11.
X plus 11. How many Swedish medals?
X.
So if you add X plus 11 to X, you just told me what's got to happen.
Oh.
Okay, yeah.
Where would that come from?
X plus 11, or X plus 11 plus X. Like, I don't understand.
That's, yeah.
I thought it'd just be X plus 11.
X plus 11 equals 39.
Because
You have to combine like
Because-
the mixed up.
it's sort of like saying, it's a little bit easier when I'm talking about building a fence, I think, because then we can visualize it a little bit better. But let me try it on this, and then we'll do a fence problem so I can show you really physically what's going on. If you said this, then you are telling me, and again, what is this the name of?
That's the U.S.
That's the
medals.
U.S. So you're saying the U.S. by itself won 39 medals. That ain't true. That's not what it says, right?
No, I know that, but shouldn't you have used a different variable?
Oh no, you're thinking ahead a little bit. I could use a different variable to solve this, but I don't need to. Why? These are not totally individual. One depends on the other one, right? So like we said, if Sweden was 7, then the US would have to be 18. Right?
So if X was 7.
So if
then
X were
it'd be
7,
Plus 11 plus 7.
but I'm not saying it makes the right number 39. I'm just saying, based on that first sentence, if the Swedish medals were 7, how many would the US have? 7 plus 11, right? So I was saying that just to make sure you guys understood how to build this. We don't know how many Swedish medals there were.
28.
So we got to call it X because we don't know what it was. But then what must the US medals have been?
11 more.
X plus 11. So what you're doing is, I don't know if it's 7. If it was 7, what would I do to get the US? Add 11. If it was 20 medals for Sweden, what would I do to get the US? Add 11. So what you're saying is, Screw all that shit. I just always add 11 to whatever this guy is. Isn't that what that says?
Yeah.
Whatever this guy is, how do we get
Where's
this guy?
the other X?
Add 11. So watch this. If I, a little side note, if I always make twice as much as my office mate, right? Whoever's in my office, somehow I always make twice as much as them, right? It's just my contract. I don't know how I did that, but let's just pretend I did. Whoever's in my office with me, I better make twice as much as them. Right? For some reason, they said, okay, what the hell? So, if somebody comes in my office, so here's me, and if somebody in my office partner comes in, and they're making $40 an hour, how much am I making an hour? 80. All right, and then they leave because, I'm a dork. I'm like, ugh, I always find twice as much as you. So eventually they say, screw you, get the hell out of here. So the next person comes in, they're making $25 an hour. Well, then how much am I making? 50, and the same thing, right? Well, even before the next one comes in the door, how much can I say they're going to make? I don't even know who they are. I don't know how much they make. They make X, some undetermined amount of money. How much must I make then? 2X. It's not that there's a whole other X. It's because my money is based off of what they're making. So if they make something related to X, I'm going to make something related to X. In this specific case, twice that.
Isn't it already there though? The X, you just took that X and put it over there. So isn't it already there?
Yeah, it's the same X. It's just relating to me that I'm twice as much as this guy. So if you wanted to, you could use the letter Y. We normally use the letter X, but if I use the letter Y, what would I be? 2Y.
So how would you solve that?
That's the easy part, right?
Yeah.
Once you get the equation set up, that should be the thank God part.
Yeah.
It's hard to get to the equation. What should be easy, what's the matter?
I just want to let you finish the problem.
Oh, okay.
Me too.
You were waiting for the end. This is not the end,
Yeah,
yeah.
that's why I was like, what do you, I don't get it. 'Cause
All right. Yeah, this is not the end. And then I thought, you're not good with where I am, but you're just waiting for me to get to the end. So how do you solve this? You solve it like you always solve it.
Like terms together.
Like terms, 2x plus 11
That's why I was so mad.
is 39, right? Let me bring it up here.
And move the 11 over there. And
Yeah.
this 11.
So let me put it up here. So we got this right now. Subtract the 11. 2x equals 28. 14. So those of you who kept saying 28, you're making a mistake. You were thinking ahead. That number does pop up, but it is not an end result number. That's an end result number. Now, you got to be careful. The really cool thing about doing this is you can answer the question very easily. If you leave it like this, you're wrong. Because they want to know each country. You didn't even tell me which country this is.
That's Sweden.
All right, so you better come over and you can just go over here and say X is 14. Circle that. So Sweden had 14 medals. So how many medals does the U.S. have then? 25. And does that do what it's supposed to do? What are the number of medals supposed to do?
Add up to 39.
And they do, thank God. So you can always check your work. Do they do what you're supposed to do? 25 plus 14 is
I'm sorry, where did you
39.
get the 25 from?
Whatever these guys are, the U.S. is 11 more.
Right, okay.
So if X is 14, what's 14 plus 11? 25. Yeah.
What I do, I subtract 11 from 39. After that, I divide 28 by 2. So that much.
That's what I did. But you better show me the algebra. Don't just do that in your head.
I didn't do any algebra.
Well, that's a
What
problem.
did you?
I've got to be direct about this. Like I said earlier, I am not trying to discount your intelligence at all. I know a lot of you guys can do a lot of these problems in your head. I love it. That's great. What's more important for this class is that you do the algebra correctly, right? And if you learn how to do it on an easy problem, then you're able to do these same steps on a much harder problem that you can't do in your head. I don't care how good you are at it. Right? So you have to show me the algebra. You can't skip that. If you do, it's wrong. Yeah.
So you do algebra, how do that?
So at the very end, what you do is you go back to how you describe these two things. Sweden won X medals, but now we know what X is. So Sweden won 14. The U.S. won X plus 11. 11 more than Sweden, so 11 plus 14 is 25. Because what's X?
14.
14. So what's X plus 11? 14 plus 11.
So the answer would be 25 and 14.
Exactly. And to check it, 25 plus 14 is 39, thank God.
Yeah, that's what I was. What do you want to see as the answer? You want to see U.S. medals?
You can do it right here. Now this is just for me emphasizing something earlier.
Right.
You can set up the problem here, work it, and at the end come back here. So you make sure you answer everything, right? The big mistake is people stop here,
Yeah.
when actually there's more than one part of the problem. Okay, I don't know, maybe. So like some of you are not liking this because you're not sure how to do this, and some of you are not liking this because you have a quicker way to do it. So it's full spectrum. Let's do, like I said, let's do a fence problem. I'm kind of getting ahead of myself a little bit because they really break, in this book, they break it down section by section. The next section is geometry. But I think I can go there now because I've got all the steps to word problems. Here we go. And I'm not talking about transversals and crap. We're not talking about side angle, side proofs. No, I'm talking about just what's the perimeter of a rectangle? What's the area of a triangle? Right? That kind of stuff.
Geometry is so much easier.
Yeah, once you remember all the rules.
And in the back of the book, there are all the formulas.
Oh.
If you don't see them in the sections, it's all in the back of the book. They say,
Geometry.
and that happens. Normally, it's two different parts of the brain. If you're not good in algebra, you're normally better in geometry.
I took 2 years in geometry, high school, 1 year of algebra because I hated algebra. I took 2 years of geometry.
That's what I did.
Yeah.
So you guys should probably kick ass on this part then. Here we go. So here's the problem. And this one I'm going to add a step 0. Over there, it didn't make any sense to draw a picture. I could draw a medal. I could draw the U.S. It wouldn't really help me with the problem. On geometrical problems, drawing the picture definitely will help me keep it straight. So let's say I want to make, I've got, now I've got to make it work. Let me think a second.
It was 2.5.
Yeah, do we change section?
Oh, yeah. So let's see. I'm trying to make it work. Right. Okay, that one. Yeah. All right. I've got 80 feet of fencing. This is officially 2.5. We're going to kind of go between 2.3 and 2.4, 2.5, or 2.4, 2.5, 2.6. They're all word problem stuff, but they really broke it out into the different types of word problems. I want to make a rectangular pen for my pet goat.
That's like fencing.
Yeah.
Fencing, yeah. Not the one with the...
Don't they have that here so far?
Yeah, they do. Yeah, I think they do, guys. Seen them on the tennis courts doing that.
Really?
Not here, but somewhere. I want to make a rectangular pen for my pet goat. I need, for whatever reason, I need the, what do you need, Jeff? I need the length to be 5 less than twice the width. Now right here is normally where you would kind of tune out something and say, hopefully he doesn't really look at this problem. Possibly, I don't know. What I'm really trying to get you guys to do is realize you want to break it down into parts. You're not supposed to be able to just jump to the equation right now, right? You really, somebody might be able to, but it's not that easy. You want to do it part by part. So step 0 is draw the picture, right? So the question here would be, what are the dimensions? What's the length? What's the width?
Well, you have 80 feet. That's the length.
No.
No.
Wait,
And again, if you made 80 feet the length, my goat's going to run away.
well,
There's nothing keeping it in.
No, I mean that's how much you have.
True.
And
So
you
you-
need rectangular, so you need to break down into fourths. maybe.
But it's not a perfect square necessarily.
It's not fourths.
But
Yeah. So step 0,
Draw a picture. It's got to be a rectangle.
step 0 is draw a picture. So draw a rectangle. Yay.
there we go.
And then we're going to use that picture to kind of keep us grounded because it's a very common mistake with this kind of problem. So that's the only new step. That's why I call it step 0, is because sometimes drawing a picture won't help. Right? We're talking about a shirt is on sale. You don't want to draw the shirt. It's not going to help you. What was step 1 again? What was step 1?
Identify the.
Yeah, identify the
How many
players.
players?
What are the players here? Don't bring my goat into it, right?
Mm-hmm.
So you
You
got.
got the 80 feet of fencing. You need length of 5 less than twice the width.
What are the things I need to know, really? What are the things I'm trying to solve for, really?
The length and the width.
Length and width. So there's only 2 players.
Yeah.
The 80 is what they do with each other, right?
Right.
It's not its own thing. It's what the length and width do with each other, right? So the players are the length and the width. Step 2 is which one is going to be just X? Which one does the other one depend on? Why do you say width?
5 less than
Which
twice.
is on the length.
So yeah, you got to identify the width because it's 5 less than twice.
Yeah, the length is something to do with the width. So I better know the width first because then I can do all this crap to it to figure out the length, right? Do you guys see how to see that? The length is blah, blah, blah width. Okay, the width better be X or W or Z, whatever letter you want to use, it doesn't matter. I better call the width something first. So if I call the width X, step 3 now is build the other guy.
Yeah, step 3. Yeah.
I love it. So 5 less than twice. So 5 less than twice the width. And what's the width? X. So see how I could never write this down unless I had him. So, real quick. The biggest mistake I see here, and this is going back to what I was talking about earlier about it's easier to show you with like a fencing problem because you can think physically about it. And you sort of made this mistake earlier, but not really. I always see somebody do this. They key in, they read through, and they say, oh, 5 less than twice. So 5 less than twice. And there's another number there. Now, physically, what's going on there? What is 2x minus 5? That's just the what of my pen?
Area.
No.
The diameter.
What is it? Look, we already know what that is. It's just the length. So what they're doing is they're doing, like we said earlier, and it wasn't really what you meant, but they're just making the length 80 feet. Do I have any fencing left? So then I put my goat out there, and my goat says, screw you. Right? So that's the mistake they're making. They keyed in on the algebraic statements, and they thought they were good because they were making algebra. It was wrong algebra, right? And of course, the other big mistake is I get somebody write this somewhere, and you can see why they would do that. 5 less than twice. They did it the way they read it, not the opposite. That less than is evil. And that's when you start getting these negative side lengths. Like I made a goat pen out of black hole material. What does negative length mean?
Nothing.
How long is that board? Negative 8. What? What does that mean? It's antimatter board. No, so let's try to solve this correctly over here. So let's see. Let's go back and put this on our picture. The length is 2x minus 5, right?
Yeah.
And the width is x. Now the next biggest mistake I see is somebody says x plus 2x minus 5 equals 80. Because they say, oh, here they go. There you go. What's wrong with that person? What'd they do?
Same thing.
They only went halfway. They at least got something here and here, right? So what they did was they did this. X plus 2x minus 5. So my goat again says, oh, I can't go that way, but still, screw you. Right?
Uh-huh.
So if you look at the picture, it'll keep you in, what's the perimeter? You got to go all the way around. So x plus 2x minus 5 plus x plus 2x minus 5. So I make sure that I keep my goat penned in. Yeah.
Interesting.
Now that equals 80. Some of you guys might realize if you did this, you could actually make it equal to 40 because you went halfway. Now if you don't think of that though, you can always do that. Just get all sides in there and then it will equal the total length. Right? And now it should be the easy part.
Yeah.
We got to the hard part, which is getting to the freaking equation. Now should be the easy part.
Is that my turn?
What do you get? Yeah.
6x
6x
minus 10.
Let's see. Add 10.
Yeah.
Okay. Add 10.
Divide by 6.
We'll divide by 6. Let's see if I did this right. I did. Yay. I was trying to make it come out to nice whole numbers. And it did.
15.
So x is 15. So then you go back and you say, okay, what was x? X was the width.
Yeah.
Yeah.
15.
And I'm going to be a little anal here. It's not 15, it's 15
Feet.
Because I will be a complete dork. If you leave 15, I will say 15 shoes. 15 light years, you know, I'll put that, but 15 feet. Yeah, so those of you that had chemistry or something already, you know, you gotta have the units in there, right? You've seen this before, you have the units down. So if that's 15 feet, that's because we just solved for x. X is the width, 15 feet. What's the length?
2 times 25.
Yeah, 2 times that, 2 times that,
Minus 5.
minus 5. So 30 minus 5,
25.
25 feet. Sweet.
That's what I said.
Right.
So if you want to check it, 2 of these is 50, 2 of these is 30, 50 and 30 make 80.
80.
So it works. Thank God. It's very tempting to try to go straight to the equation, but very often that will be when you leave something out.
Yeah.
You just go back one step, 3.
Yeah, step 3. Step 2 is which one's just x. And the minute I know that the width is x because the length depends on him, then the length is 5 less than twice that. And that's x. So what's 5 less than twice x? 2x minus 5. Right? 5 less than twice this. Cool. So the minute you know which one's just x, you can build the other one off of what you see here, what the relationship is. And again, just don't make that mistake. Okay. Let me. What do I want to do? Let me give you the handout. I want to do the handout because I got like an example on there.
So after we do this, it can't be, my answer can't be just 50 feet, right?
Yeah,
to go
because
back.
the question is the 2 bars,
Yeah.
so the length and the width, all the dimensions.
So the answer is both the length and the width you have to get back. Jeff.
Yeah, twice x minus 5. X was 15. So twice 15 is 30. Minus 5 is 25. So you really just plug that number back into what you've written. So it's really cool. This helps you set up the equation, and then it helps you answer the question. It does double duty.
For the answer, do you want to see the 2 times 15 minus 5 equals 25, or do you just want 25 feet length?
Yeah, that's
15
fine.
feet?
If I see this work, and then you got both of these numbers.
Okay.
Cool.
This is for us to do together. Or are we gonna just work it out?
I'm letting you guys look at it here for a second.
I'm just trying to figure out if I should write it on my note paper, or if I should write it on my line paper.
I got you.
I'm just trying to figure out what you
Yeah,
want.
this is not something to be turned in.
No.
And actually, we could do probably most of these. So what I want you to do is get into groups. You can do it on the back. You know there's your paper. This is for you. I want you guys to work on it, and then we'll do them up on the board.
Okay.
Right? Does it make sense? I try to do the same thing I teach. I didn't really put the step numbers down there, but you can see them all happening. What are the players? What's just X? Build off of that. Translate it to math. Go from there. So with a triangle, there should obviously most of the time be 3 players, either 3 sides or 3 angles, right? Who remembers what's true about a triangle's angles? Any triangle's angles have to add up to be
180.
180. I love it.
Nice.
No matter what the triangle looks like. Yeah, because it's basically always half of a 4-sided thing, and a 4-sided thing will always have 360 degrees in it. So half of that is 180. So that's why every triangle is 180 total degrees. Cool. So, everybody understand? Try to group up. If you don't like groups, you can be a group of 1. That's fine. Try to work on these problems at the bottom. Call me over if you need help.
For some reason, people think that like okay, I forgot what like A squared plus
That's what that. Okay. No 180.
Certain triangles are
sides. This side's A, this side's B. It's a 90. And this side's C. A squared plus B squared.
equals C squared. Okay, then what would the equal 180 squared?
That would just be angle A. Equals 180.
That's so much easier than
C and A plus B plus C.
Okay, so that's the angle.
With the little a and the little b and the little c, that's for right triangle for the sides.
Yeah, think about the hypotenuse is going to be bigger than
That has nothing to do with 180 because if you're really big or really small.
Alright, so that's
Pythagorean theorem, that's just what angles do. There's no real name for it.
okay.
Yeah.
Alright. Thank you. Sure.
stuff is amazing.
Yeah. Do you know about our geometries where triangles add more than one? They're called non-Euclidean.
Yeah, no.
Remember that?
Yeah,
That's really neat, really.
I think I like just like having something, a shape, visual. That's what I am. Like I'm looking.
You got that?
It says, visual. I need something, and so someone can. Okay, you see the circle? You have all the flowers, the triangle. Now we're gonna solve for it.
It's like a lot of work on hand, drawing yourself.
Ready?
I did really
Let's
well.
do this, man. Let's rock it. When 9 is added to 4 times the number, the result is 37. When 9 is added to 4 times scratch paper. 9 is added to 4 times the number. The result is 37. Find the number. So this isn't any sort of geometry. This is just do the problem. 9 is added to 4 times the number.